Hey everyone, this is a quick explanation of the Rocket Balloon Challenge. My name is Katie, I helped develop this lab, and let's jump right into it. So the prompt is, NASA is looking for creative ideas for launching heavy payloads into orbit, and the goal is to construct a rocket balloon that carries the most payload, which are paper clips, to space, which is the ceiling. And on the right, you can see a list of materials that will be provided for making the launch system and making the balloon. Here's an example build of me acting as a student making the rocket. So I laid out paper clips by linking them together, and I was trying to use as little extra weight as possible, so that's why I was trying out that method. And then lining up the straws so that it'll launch correctly. And also, what I skipped there was that I had to make sure that the opening was very tight by using tape and twisting the end and a clip. And this middle picture is another example of how the payload can be attached. This is supposed to be a very creative activity with many different ways of doing it. And here's a quick video of an example launch. As you can see, it didn't go all the way up to the ceiling, and that's totally okay because we're supposed to be making it better with every test launch. So if I were doing this lab, I would be launching the balloon more times to make it better. As for lessons learned with the testing setup, tape can cause paint chipping, so we need to emphasize asking a guardian for assistance. And also the string must be taut. The rocket will go in a straight line. This can be done by holding it down with your hand or using a weight for assistance. For building the rocket, the most important part to get started is to twist the opening of the balloon and secure it closed. Because if you can't do that, then you can't build everything else on it. So what I found what worked best to keep it closed was twisting it, then clipping it closed, and then putting tape at the end to make sure it's secure. For repeated launches, we can tell students to inflate to the original size of the balloon so that they get consistent data and that every launch the balloon has the same amount of air in it. And this is the most time-consuming part of the lab, so if you're running out of time, it may be because we're doing too many repeated launches. So one way to go along faster through the lab and to make it to other parts is to reduce the number of launches if that is needed. Now on to troubleshooting tips. If students are having trouble with inserting an image of a drawing, and this would be in the workbook, instead of using an uploaded image, we can suggest using Google Shapes, which is in Google Slides. And then to do this, you go to Insert and then Shape or Line, and they can make their drawing in the slides. For constructing a rocket, we can suggest starting with a simple design, such as just blowing up the rocket and not including any payload, just to get the feel of what it's like to build it. And we should make sure that the opening is secured while they're building it. As for launching the rocket, some tips are to check that the straws are aligned correctly, because if they're not, that can cause problems, and to make sure that the launch string is taut. And that's all we got for right now. Feel free to reach out if you have any more questions, and I hope the lab goes well. Thanks for watching.